Okay, so hello everyone, welcome. Can you hear me? Okay, thank you. Just wait, we are waiting 1 minute, then we'll start. Okay, so we'll start today's session. So basically today is our third number days, and I hope already all of you already get all of recorded class and also practice code. So after completing the 3 hours live training program, then we talk about the problem solving for previous classes. Okay, so let's go. Let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank you. So let's go. So basically today I talk about that how we can easily calculating any indices using different types of satellite imagery, Landsat or Sentinel, how we can easily use this type of satellite imagery and how we can easily calculate the different types of indices. And we'll talk about that how we can easily filtering and displaying the satellite images, mainly Sentinel-2 satellite imagery, and further how we can easily monitor the different types of indices such as normalized difference water index or normalized difference vegetation index, as well as we also discuss about the Otshu thresholding technique, how we can easily use and extract the water body or vegetation. Okay, as well as we also discuss about the time series chart, different types of indices such as ndvi, nwi, or other any types of indices, how we can easily make the time series chart and export any shapefile. We'll also talk about that and how to add the gradient legend, as well as we'll also discuss about the flood mapping, how we can be using the Sentinel-1 star data, and we'll also talk about the monthly time series chart, how we can easily create for different types of indices. So let's go one by one. I try to complete all of topic. Okay, let me open my slide. So first of all, when you filtering the Sentinel-2 satellite imagery, just we are applying the same process for filtering also. So first of all, we need to take our study area, which area you want to work. So simply import your study area. So this is the one kind of factor. Previous class I already discussed about that, this type of filtering factor. Same process we also apply for Sentinel-2 satellite imagery also. And also filtering the image metadata, less than 1% cloud cover, and for a specific time period. Okay, so let's go practical example. I try to show you all of details one by one, and today's session I also try to show you that how we can easily find out that water logging area in the Dhaka city boundary for that rainy season and also dry season. We just compare these two time period, and then we just try to identify for water logging place in Dhaka city boundary. So let's go. And in this case we are just applying that Sentinel-2 satellite imagery. So first of all, simply import your study area, which area you want to work. Suppose in this case I want to work for Dhaka city boundary, so just simply open import your study area. Okay, so this is a Dhaka city boundary, so I want to work with this boundary, so just simply import. So this is my settle boundary, just import. So it show the default variable name as a table. So if you want, you can put any variable name. I put the name, suppose ROI. So in this case I want to filter the satellite imagery for 2 time period, and I want to work for Sentinel-2 satellite imagery. So for that, simply go to the browse data catalog and call your data. I want to work for Sentinel, and from here you can easily find out that Sentinel-2 multispectral instrument, and in this case I want to work for top of atmosphere reflectance for Sentinel-2. So this is my image collection for Sentinel-2 multispectral instrument. So here you can see all of band, every information can easily get it from here. So now this image collection simply import in our code editor. Just copy this snippet ID and then paste here. Then simply give a variable name. We can put any variable name. I put the name, suppose Sentinel. Okay. So now this image collection we just simply filter for this procedure. I already know about that. Suppose I filter for a specific region of interest. Just put here the filter bounds with my study area, which is ROI. Further filter, suppose metadata, and we already know about that. In this case we are just import the image properties. Okay, suppose I choose for this image properties cloud pixel percentage and paste here and put the operator less than, suppose 1. Okay, and then just if you just put how much image is available, for that just print and call the Sentinel and use the size function. So now it computed how much image is available, less than 1% for my study area. We find out the 276. In this case I am I not add the filter date function, because I just filtering this image for 2 season, suppose summer season and also rainy season. So I find out that this is the total image collection for my study area in Dhaka city boundary, less than 1% cloud cover, total 276 images. So this 276 images, now I just make a variable and store it all of image for the summer season, and also take the another variable, then store it that all of image for the rainy season. Okay, so let's go. Wait. So just take a variable. I put the variable name, suppose dry season or dry image. I put suppose dry image, and now I just call the Sentinel. Just copy from 276 images. I just choose only for those images which images are available in my dry season time period. Okay, so for that just use here the dot filter date function, and I put here suppose specific time for the dry season perspective of Bangladesh region. Suppose in year of 2020, suppose of 2020 1st January, from year of 2020, suppose 05 31. So I put this type of time period for the dry image. Further, if you check how much image is available for the dry season, just call the dry image and use here the size function. So now it's computed how much image is available for the dry season, basically between this time period. So between this time period we find out that 20 images are available. Okay, and now also take the another variable. Suppose just take a variable for, suppose rainy image or rainy season image. You can put any variable name. Just call the Sentinel. From here I just take only for this image which images are available for my rainy season stage or rainy season time period. For that just put here filter date again and put this time period, suppose year of 2020 06/01 from 2020, suppose October 31. So I put this type of time period, and now I want to check how much image is available for that. So just call same process, copy this variable name and use the size function. Okay, so now run the code. So now we find out that in the rainy season, so basically in the rainy season, a lot of cloud we find out in the sky. So that's why you can, in this time we find out very only for the 2 images is available, and this 2 images is the less than 1% cloud cover. Okay, but you can see when I just filtering this image for the dry season, we find out the 20 images. 20 images is the less than 1% cloud cover. Okay, so we find out this type of things. If you want, suppose we all basically this filter metadata function we are used for filtering image properties. Okay, so if you want, you can also use the another function instead of the filter metadata. This function called as a short function. Suppose I just put here the short and then call this cloud pixel percentage, control C, and I just paste here control V. In this case, basically this filter metadata function need when you want to set a level. Suppose I need the image less than 1%, I need the image less than 5%, 10%. So a specific level when you filtering, then you just put the filter metadata. But when I apply the short, in this case, I shorting my image collection. I take all of cloud pixel imagery in this case. So in this case, you can see just I simply commenting this line, and now I run the code. So now it also increase my image collection. So here you can see we find out that it's total 1147, and I find out that in the dry season imagery we find out the 60, as well as also rainy season imagery we also find out the 60. So in this case it's just increasing the image collection when I don't set any kind of level, but previous time when I just use the filter metadata, then I set a level. So now this 60 images have lot of cloudy pixel or noisy pixel are available. But when I just use a boolean operator, in this case suppose I just put here that false boolean operator, this false boolean operator automatically remove all of cloudy pixel or all of noisy pixel, automatically remove from here, and we find out very neat and clean satellite imagery. Okay, so let's go try to visualize the image. So in this case we find out that dry image 60, also rainy image we find out that 60 images are available. So now I want to create, we already discussed about that one function, basically median. So this median function basically an image collection by calculating the median of all values at the each pixel across the stack all of missing bands. In this case we also discuss about the another function, this function called that suppose mosaic, and mosaic is also applicable for the image collection. Okay, so this mosaic I already created the image collection for the dry image 60, also rainy image 60. So now I can easily apply the mosaic function. So mosaic mainly composite all the images in a collection using mux. So now it not calculate any kinds of median pixel value, any kinds of average pixel value. It just create the composite all the images in a collection using the mux. Suppose I want to use it, so simply copy this function and then dot mosaic, and further just clip with your study area, which is RY. Okay, same process you also apply in here. Dot, I just create the mosaic, composite all the images, and further using the mux, and then clip with my study area RY. Okay, so now if I run the code, we find out an error because we already discussed about that, because size is only work for that collection. But when I put the mosaic, then this variable it's not stored the collection, it's just a single mosaic composite image. So for that size is not work, size is only work for the image collection. So just I remove the size, also remove the size, and run the code. Now it computed as an image. You can see the type is the image, and this image contains all of band b1 b2, all of band is available for that too. So now I want to visualize this satellite imagery for the 2 time period. So for that just use here map dot add layer and call this dry image. Further also take the another layer for rainy image. Okay, so now run the code. It just added the two layer but not focus on my center. So for that, just use the function map.center object. Map.center object is mainly ry, and I put the zoom level suppose 10, and now run the code. Okay, so it look this type of color. So I want to add the visualization. Just click on here, and in this case you can see we find out this type of value. Okay, this type of spectral signature value, this type of value is not reprojected the scale value. Okay, so if you check the scale value from the bands information, you can see it already provide all of bands are the same scale. Okay, all of the bands are the same scale. So this scale value, when you multiply, then we can get that proper rescaling spectral signature values. And it's very important to get the proper pixel value. So just I want to just multiply this scale value with my, after mosaicing, just I put here the multiply and then paste, and also multiply and then paste. Okay, so now run the code. Okay, now try to set that visualization. Suppose red, green.
Excuse me, sir.
Please.
So from where we take that value 0.001?
So this value basically is a scale value. You can see this is the bands. This
Okay.
scale value basically provide you the proper spectral signature value. We find out. Okay.
Okay, okay,
Okay. Otherwise, it show very long value. So that's why this type
okay.
of information, basically when you check any data set have the scale value, just try to use this type of scale value to get the proper pixel value or spectral signature value. We find out the proper.
Um,
Okay. So further, just check 98% and then try to apply. Okay, find out this type of imagery and just import this visualization, and then copy this variable name and I put it's a dry image. Same process also applicable for that another layer. Just click on here. I set suppose before red, green, and blue. Stressing 98%, and then apply. Okay, now you can see we find out this type of imagery, and this imagery we find out that this type of cloud, and this image is not more bright. We find out this type of cloud, and this image is also not more bright. So for that, you can simply increase the gamma value. Suppose just increase the gamma value and then apply and then check what happened. Okay, so now it also increase the brightness. Okay, but this type of cloud, further class I will discuss about that how we can remove the cloudy pixel. Okay, and get the very neat and clean satellite imagery. And you can see these are two imagery we find out. One is the dry season, another is the rainy season. Basically dry season you always we find out that very neat and clean satellite imagery. This is the dry, and this is the image for rainy season. Rainy season we find out this type of cloud, but this type of cloud we also further try to learn how we can remove this type of cloud. Okay, so now just copy this variable name, just copy and set after that, and I put it's a rainy.
I have a question.
Please.
Sir, actually, if you take an example for 10 into 10 meter resolution Sentinel-2 image in a specific area, that I would be helpful for it.
Okay, so in this case, this imagery resolution is the 10 into 10, mainly 100 meter square area cover, 1 pixel or 1 cell size is covered. Okay, suppose if I zoom,
Okay.
then you can easily get that pixel or grid. Suppose you can see just I more zoom. Yeah, so this type of cell, you can see this type of cell. Yeah, this type of cell or grid, this area mainly 100 square meter. Okay, so pixel size is the 10 meter. So that's why this resolution is also more good than Landsat imagery. So we find out these two satellite imagery. One is the rainy season, another is that summer season. So now these two satellite imagery I just use, and further I try to extract the suppose water body. Okay, so I want to find out that water pixel from this satellite imagery. So extract the water body. We are just using the different types of indices in remote sensing for water index. So you can simply search on the Google. Suppose just simply search water.
Sorry, sir.
Yes, yes, can you show me water index?
Back to the screen.
Yes.
Sir, actually, is this the Dhaka image? Is the combination of some Sentinel-2 image?
So it's the full Sentinel to satellite imagery.
Sir, I am questioning about that. Is this Dhaka image combination of how many images?
So we already check it. We just create the mosaic for 60 images.
Okay.
Okay. So before that, size function is work, and we check it how much image, and we also check all of images date also from here. Okay, just when you just put the size function, and size is work before applying the mosaic or create the
If
composite.
I, sir, actually, if I working in a specific image, then the picture quality will be enhancing or decreasing.
Yes, so it also decreasing. Okay, when you want to work only for the one single data imagery, so when you create the mosaic or composite, then pixel quality is also more better, because at the same time it create the combined total 60 images, so that's why you also get the more better. But when you want to work for the single date or specific without composite, we can get that normal imagery, but it also possible to use in remote sensing also, no problem.
If you have any village boundary in your country, um, anytime you can take an example for that,
Uh,
and I will be
okay, no problem. You also
helpful.
try to find out your village country and try to apply. Okay, just simply take the plot. Okay, and then try to apply this type of Sentinel to satellite imagery and plot area. It will be more better. You try to take the plot area if 100 meter square area greater than 100 meter square area, then we can easily recap this type of information for this boundary. Okay, but your
So
plot area is very small, but you want to apply the 100 meter square satellite imagery, then you cannot get the more better result. Okay, then you need to also increase the increase the high resolution imagery, you also need to use.
sir, actually, if the plot area is that 1 kata to 5 kata, is this applicable for that?
Okay, so you'll also try further, you'll try to check your study area for the Sentinel 2 satellite
Okay.
imagery, then check what types of visualization you find out for that. Okay, you can just simply just same process, just filter bounds with your study area for plot area or your village boundary. Okay, then check what happened.
Thank
Okay. Okay, so now we are just extract the water body from our boundary. So for extracting the water body, we are using the different types of water index. So in the remote sensing, we are using the different types of water index. I can see these types of water index and their application. So this type of water index we are use in remote sensing to extract the water body from satellite imagery. This is the one kind of water index. It's called the NDWI, mainly normalized difference water index. So this is the formula about that NDWI. So when you just apply this formula, then we can easily find out that normalized difference water index. And there are a lot of uses for that: monitoring change in water content in the leaves, and more analysis the susceptibility of study area to fires, more in the plant fertility, detection of the surface water, measuring the extent coverage by surface water. Okay, as well as you can see this is another one for water ratio index, WRI. So this is the formula about that: WRI, green plus red divided by green plus short of infrared. So this type of formula, when you just calculate, then we can easily find out that water ratio index. And they're used for ecosystem psychology and detecting water bodies, study areas. So there are a lot of index we are used at the different purpose. Also you can see it's called the MNDWI. Okay, mainly modified normalized difference water index, and this is the formula about that MNDWI. Okay, also you can see this is another one. So basically it's what for that sono index. So when you extract the sono area, then you try to use this type of index. This is the formula about that. Also you can see this is the normalized difference thermal index. It's calculated using this formula. This is the formula about that, and it's detecting the water turbidity. Okay, okay, so let's we try to apply one formula, water index formula, and then further from this satellite imagery we try to extract the water body. So for the water body formula, suppose I want to apply for this formula NDWI. This formula is that NDWI, suppose green minus near infrared divided by green plus near infrared. Okay, so this is the formula, normalized difference water index, and this formula I want to apply for these two imagery, for the rainy season and also dry season imagery. I already created this imagery, so now this formula I want to just simply add. Okay, so for that calculation we are just use the different way, different method we can apply for calculating this type of index. So in this case, if you want, you can use some built-in function. Suppose I just call this function. This function automatically calculated this type of equation. Okay, in Google Earth Engine is available this type of function. Suppose I simply open the docs tab and search here function name normalized difference. Yeah, so this one function you can see, and this function normalized difference function only applicable for image. Okay, this function you cannot add in the image collection. So e.image, so I already create the image, rainy image and also dry season image. So now I want to apply this function normalized difference. And what is the normalized difference? Mainly it computed the normalized difference between two band. Suppose you want to calculate a index, and this index only have two band. Okay, so this normalized difference is computed first band minus second band divided by first band plus second band. So in this case my first band is the green and second band is the near infrared. So just I use this function, normalized difference function, and set the band name. Okay, suppose first band I set green and second band suppose near infrared. So then this function automatically computed first minus second band divided by first plus second band, and you can see what I returned. I returned the image. It also returned the new image. New image mainly NDWI. In this case I find out that NDWI map when I just use this formula. And this function, this built-in function is only work for two band. Okay, this it's work only for the two band. Okay, suppose you calculate any index and this index look like that. Suppose first minus second divided by first plus second. This type of equation we can simply calculate using this function. But some index are not this type of um, structure. So suppose EVI or SAVI or other types of index, you also check this type of index have not this type of structure. So for that we also need to apply the another method to calculate this type of index. So further I also explain about that. But this type of formula, suppose first band minus second band divided by first band plus second band, this type of formula we can easily compute it using this function easily. Suppose another example I will show you that. Suppose NDVI formula. NDVI formula mainly near infrared minus red divided by near infrared plus red. So you can see this is the same construction, first band minus second band divided by first band plus second band. Okay, same structure we find out using this function. Okay, first band minus second band divided by first band plus second band. So now I can also calculate the NDVI or NDWI using this same function. Okay, so any kinds of index or indices have this type of structure, suppose first band minus second band divided by first band plus second band, then you can easily use this function and compute this normalized difference between two band. Okay, so let's go try to use this function. Suppose I want to calculate take a variable, suppose ndwi, suppose dry, and now just call the dry image. So I already created the dry image, so this dry image, this variable stored the dry image, just copy and then paste here. So now I apply this function normalized difference, so just put the dot notation and write the function normalized difference, then mention the band name. Basically I need the green band and near infrared band. First band is the green, and green call as a B3, and near infrared call the B8. Okay, so you can check the band information from here. B3 is the good. So just I put this function normalize difference and put here the B3, which is my green band, and B8, this is my near infrared. Automatically calculated the green minus near infrared divided by green plus near infrared, and it is stored in this variable, and it returned as an image. So if you just put here the print and check the data type, just Ctrl C and then paste here, Ctrl V, just run it. So we find out the image. Okay, and this image have one band. This band name, default name is the ND. It show the default name as the ND, and it's a floating number belongs with -1 to +1, basically range of NDVI or NDWI. Okay, so it show the ND. If you want, you can also change this band name. So for that, just use here the dot rename function, put here the dot rename and put the new name, suppose NDWI, and run the code. So now it show this type of name in this band name. We find out, just click on here, you can see this band name shows the NDWI because I just rename it. So now I find out this NDWI image, and this image I want to visualize in my map. So just add a layer, map dot add layer, and call the NDWI dry, just copy and paste here and click and run the code. So now it's added the layer of NDWI map. So from this map we can easily detect the water body. So it show the grayscale color. So further, if you want, you can also add the purple color. So for that, just click on the right click on here, and then you can see it show the NDWI, and I just stressing suppose 98%. And further I want to set the color combination. Suppose okay, suppose I want to set the color where there is no water, show as a red color, greater than show as a yellow, then show as a suppose green, and water body show as a suppose blue color. Just I put this type of color combination. If you want, you can also use any types of color combination and further apply. So now it show this type of water body. So let me just import this visualization and further copy this visualization parameter variable name and paste after the object name. Just paste here. and I put the layer name. Suppose it's a NDWI for dry. Okay, so now it's create the one NDWI map, but I also need the another NDWI map for that rainy season. So same process we are just applying in here. Just take a variable, suppose NDWI rainy, and further just call the rainy season imagery. Okay, where rainy season image, and it is stored in a variable. This variable name is the rainy image. Just copy this variable name and then paste here. Further, just apply the same function, which is normalize difference function between two band. First band is the B3 green band, another is the near infrared band B8. And further, I'll also put the dot rename, and I put the name as a NDWI. Okay, so further we try to visualize this map.add layer, and call this NDWI rainy. Just copy and paste here. I just run the code. So now it added the another layer of NDWI for rainy season. Okay, so now further let's try to add the color from here. Just stressing level, suppose stressing 98%, and add the color plated. Suppose where there is no water, show as a red color, greater than suppose yellow, then green, and finally for blue, then apply. And also import this color combination. Further, just copy this variable name, just copy and paste after the object name, and I put here say NDWI, that was training season. So now we create these two maps. Okay, so you can see find out this map is for rainy season. We find out this type of water body show as a blue color. This is the water body, and another this map is for dry season. Okay, so we find out that this type of map for water body, not mass water body, but you can see in the rainy season we find out the lot of water pixel. Okay, so now how I can we find out this type of thing. Suppose now I want to extract the water body from this map. Okay, suppose this map, from this map I want to just only extract the water body. So for the NWI, if you want, you can also use at the outshoe. We simply find out that threshold value from the outshoe, and further we can easily calculate this type of water pixel. If you want, you also do it normally. So both of course I will show you that. Suppose this is the map. From this map I just need only for the water body. I just need only for the water body area in the rainy season. In the rainy season map we already create this map of NWI. So now from here I just need only for the pixel of water body, this type of blue color pixel I want to need. So for that, if you just put a threshold value, suppose Suppose take a variable, suppose water area rainy or rainy season, this type of variable. So then call this NWI in rainy season, simply copy this variable name and paste here. So from here I just need only for those pixel, which pixel is the greater than 0. Okay, greater than 0, all of pixel indicating about the water body for NWI, and less than 0, all of pixel indicating about the non-water body. So for that I just put here the greater than, suppose greater than 0. So now this variable is stored all of pixel only greater than 0. So further we try to display this map. Suppose just use here map dot add layer and call this water a just copy this variable name, and it provides the binary class. Okay, suppose in this case this layer show as a binary. Binary means that water and non-water. Okay, two class we find out, water and non-water. So for binary class representation, just I take suppose mean 0 and max 1. Okay, and further I put the plated, color plated. Where there is no water, show as a suppose gray color, and where is water, show as a blue color. Mainly water and non-water. Water class show as a blue color and non-water class show as a gray color. Again I put the layer name, suppose it's a water. So now run. So I get another layer, water. So now we find out this type of map. Okay, we find out this type of blue color pixel. It's indicating about the water pixel. And this is the one kind of map for water and non-water we can easily create from here. But this map we can also create it using Odshu method. Suppose I want to just find out that from the Odshu we can easily find out that proper thresholding value. So in this case you can see I just put here this value greater than 0. Suppose I just put here that greater than 0.1. So now we find out that another types of map, all of pixel greater than 0.1. Okay, so we find out this type of pixel. Okay, so now I can see this map is also changed. Okay, but in this case we also talk about the Odshu method. So Odshu method is one kind of method or technique for selecting the threshold value to separate the pixel into two classes. Suppose in this case I want to apply the Odshu method, and further I want to create the two class, water body and non-water body. So Odshu is automatically provide you this type of thresholding value. So if you can see, just I put the randomly in this time, just I put the greater than 0, greater than 0.1. If I just put here the 0.2, then I also get the another types of map. But for my image, what is the proper thresholding value? I don't know. So for that we need to calculate or compute it, this proper thresholding value, and further I just put the value in here, then I can get more accurate map. Okay, so now I can say I can get this type of map when I apply greater than 0.2. Okay, so basically what show, it's computed the thresholding value and for separate pixel into two classes. So different types of work, suppose for the flood water or permanent water, as well as vegetation or non-vegetation. So different types of work we also use the thresholding value, and Otshu method is one kind of technique for selecting the better threshold value to separate the pixel into two classes. Okay, so let's try to discuss about that, how we can easily work with that for creating that, uh, find out the proper threshold value for our study area. So for doing these things we are just calculate that histogram. Okay, histogram for that NWI. So for that, just take a variable, suppose I just create a chart, and the chart mainly UI dot chart dot image dot histogram. Okay, and now put all of argument. Suppose first argument, so when I call here, I already create. Suppose I want to use the for the rainy season water body. Okay, this map NWI rainy. So just call the NWI rainy variable, just copy and paste here, then put here another argument for your study area RY, and put here the scale, suppose 10 meter. So now the chart I want to print, so just print this chart and run it. So you find out this type of chart. So basically it show about the frequency, and it also show about that NWI value. So if I just click on here, and you also download this type of CSV file value, because for the extracting the different types of feature using this top value you can also do it, and it's very useful for that thresholding. Okay, suppose just I put the specific value, and using this value you can easily detect for a specific feature from the satellite imagery. So now if you check all of negative pixel, so basically this type of negative pixel, all of pixel indicating about that non-water. Okay, all of negative pixel indicating about the non-water. From here you can see it will be from the negative 0.047. Also you can check that, also this one, this one, this one. Okay, so you can see it will be start from here. Okay, so from here, okay, it also 0 greater than 0, we are just put here, you can see this value 0.008. okay, greater than all of pixel from 0.008 indicating the water body. Okay, and when I select the water class, then if I just put the value 0.008, I find out that more better classification, because all of other values indicating about that non-water. Okay, so if you check from here you can see we find out that this from here, this one 0.008 from start from here, and all of positive value, indicating about that, water body class, because NWI positive value indicating the water. So in this case, if I just put at the 0 or 0.1 or 0.2 randomly, it also work, but which value is the more better? or which value provide me the more better classification between the water and non-water. So this information we can easily find out from the histogram. Just we calculate on our image. Just I call the image. Basically I want to work for NAWI for rainy season. Just call the rainy season NAWI, and further we just put here the ROI. It's our shapefile variable name, and 10 meter it's our resolution of our satellite imagery. Then simply print the chart. Then we can easily find out that result. So we find out that 0.08. Okay, greater than equal or greater than 0.008 all of pixel, indicating about that water body. So from here it will provide that all of water body, and all of negative pixel indicate about the non-water. Yes, please.
Please go through that histogram again. I kind of lost it because I only see you say 0.08, but there's still some other blue values. So yeah, like that it's 0.08, but then the other pixel before it is also a blue pixel. So how did you, or how do,
Okay,
what are you looking for?
okay, so basically for NWI, positive value. Okay, this positive value indicating about the water pixel. You can also check it. Suppose just click on here, and if you just click on the any water pixel, suppose just I click, suppose this map, this two map, just I simply zoom. For the water body we find out that positive value always. Okay, positive value indicating the water body, and negative value indicating about that non-water body all time for NDWI. Suppose if I just click on the inspector tab and click on this water body, just I click, suppose this water body I click. So now we can see for the water body area we find out that what is the value of NDWI. It show the positive value 0.3, 0.1. We find out the positive value. But when I click this type of non-water body, so you can see we find out that negative value. Okay, negative value. So always NDWI for the negative pixel, it indicating about the non-water, and positive value indicating about that water. So that's why when I just make the classification, so just I create this type of histogram. So from this histogram I can easily get the value. Okay, thresholding value. Suppose all of positive value indicating about the water body, but which value easily separate the two classes. Suppose if I just take this value, you can see it's negative. If I just take this value greater than 0.008, greater than all of value 0.008, then I can easily classify water body, because from 0.008 all of values indicating the water body, and all of negative values indicating about the non-water body.
Okay, so I get it. So you just look for the first positive value after
Yes, yes,
0.00.
yes, yes, yes.
Okay,
And if
thank
you
you.
also check the last one, you can see what is the highest value, because this value you also need further, because when I make the change, this value is also need. So you can see what is the last one. Last one is the 0.3, 0.383. We find out it for rainy season, for the rainy season. But when I compute this type of similar things for the summer season, then you can check what types of value I can get. Suppose I create the another chart. Suppose just I copy the same code, and I want to create this type of chart for dry season. Okay, or summer season. So just call this NWI dry. Just copy this variable, and then paste here, and I put here it's a chart one. I put this variable name of chart one. So now I just run the code. So now it generate this type of chart for dry season in DWI. Okay, so in this case you can check these two graph. First one is for rainy season. This is the rainy season, and last this one is for summer season. So just open it. So now if you check what is the last value for that, it's very small. 0.19 or 0.2, I think 0.2. Yeah, this one is the, yeah, 0.2. So we find out the 0.2. Okay, 0.2 is the highest pixel of NDWI for the summer season, 0.2. But if you check it for that, this value is for 0.3 or 0.4. Yeah, 0.3. We find out the 0.3 is the highest pixel value of NDWI for the rainy season. Okay, rainy season we find out that high pixel value of NDWI. Okay, but in the summer season we find out that low, it show the 0.2. So now based on this thresholding value, suppose I want to find out rainy season water body. Okay, suppose if you check suppose water body, uh you can see both are, so this is the map, for rainy season water body and also dry season water body. So I want to compare these two maps and find out only for rainy season water, because you can see some water is the permanent water body is available. Suppose this type of place, okay, let it open. Some water already have, suppose rainy season and also summer season, both time period we find out some water pixel. Okay, but I want to calculate only for rainy season water. So you can see this place, if you just uncheck, you can see this type of permanent water body. This water is already available in the rainy season, sorry, summer season. Okay, and rainy season it also available. If you just click on here, it also increase the water body. Okay, but you can see this type of place there is no water in the summer season. Also if you check for the up, this type of place there is no water in summer season, but when I open the rainy season we find out that water body. Okay, it opening. Yeah, you can see we find out the water body. So if you check also pixel value, suppose just click on the Nespero tab and then click on this type of, just click, and from here you also get the decision. If you check the pixel value both of time period, we find out that in the dry season we find out the negative. It means that there is no water in the dry season, but rainy season we find out the positive value. It means that in the in the rainy season we find out the water body for this type of place, and dry season there is no water because it show the negative pixel. Also check this type of place, same procedure also find out. So you can see negative value in the dry, negative value. It means that there is no water in the dry season, but rainy season we find out the positive value. It means that water is available in the rainy season, but dry season there was no water. So now I want to calculate only for the dry rainy season water. Okay, how much area we find out the rainy season water, and these things I calculate based on a thresholding value. So if you check from here, we find out that this one is the rainy season, sorry, summer season. We find out the highest pixel of NDVA is the 0.2. Okay, 0.2. So now I just keep a equation. Suppose rainy season water, uh, suppose just I find out the rainy season water. Suppose NDWI rainy season greater than 0.2 and NDWI suppose dry season less than 0.2. Okay, so from this highest value I can easily find out this value is the 0.2 in the rainy season, sorry, summer season. So all of pixel greater than 0.2 indicating the water body in rainy season, because less than 0.2 all of are the summer season. But when I take the pixel we find out the highest value is the 0.2. So in this case I just take the greater than 0.2 from all of rainy season pixel. NDWI rainy greater than 0.2 and NDWI dry less than 0.2, which is indicating about that only for rainy season water. Okay, so now I try to use this equation, and this value mainly we find out from this from here we try to find out that which value is the highest pixel of NDWI. for that summer season. Okay, suppose this same approach we also apply for the flood mapping. Suppose in the before flood and after flood we take two imagery, so just apply the same process, okay, for the before flood and after flood, and then check for that before flood what is the highest pixel of VH band, find out this value, okay, then set suppose 0.2, so greater than 0.2 from rainy season and then less than 0.2 from the dry season. Then we can easily detect or separate rainy water and also separate for flood water. Okay, so in this case we find out the 0.27, we take the 0.2, and now we have set this type of equation. Suppose NAWI rainy season greater than 0.2 and NAWI dry season less than 0.2. So now I just apply this condition and then check how much pixel we find out in the rainy season water. So let's go try to do it, and this value where I can get, we can easily find out from that chart. From this chart it show the 0.2 highest value. Okay, so let's go try to apply it and then separate. So for that, and just take a variable. Suppose I put the variable name is that, suppose rainy season water, or put any variable name. So now just call this NAWI map. We already created the NAWI map for two time period. NAWI map for rainy season, just copy and further paste here and use here that greater than, I said greater than 0.2, and same put here the end function and call the NAWI dry, yeah, NAWI dry, just copy and paste here and set less than 0.2. Okay, and further if I just display this map, same process, just create a binary class, so map.add layer and call this Ctrl C and just paste here, and I create the binary class, suppose min 0 max 1 plated. Suppose there is no water, show as a gray color, and if there is water, rainy season water, show as a blue color. Okay, and now run the code. So now we find out this only for those pixel which pixel is greater than 0.2 from NAWI rainy season and less than 0.2 from NAWI dry season. Okay, so now you find out this type of water body map. Okay, so if you check, suppose just click on this any water body pixel, suppose just I click on here and check the value. So you can see in the rainy season we find out the 0.25, mainly greater than 0.2, okay, and less than 0.2 in the dry season. Dry season it show the negative, okay, it must less than from 0.2. So if I just click on here, so we always find out the pixel greater than 0.2 for that rainy season. Rainy season show as the 0.3, must greater than from 0.2, okay, and we find out the negative 0.4 which is less than from 0.2 from the dry season. Okay, so now we get this type of things, so just apply this thresholding technique and we can easily separate. And if you want, you can also make the suppose single class. So it's the binary class. Suppose I just create the single class. So then this gray color map will be removed. So for that, just use a self marks function. Self marks, basically it create that single class. Okay, so now binary class not need. When I put the self marks, then binary class not need. So just remove it, it not need. Okay, suppose I want to display the water body. Suppose rainy season water body, I display as a suppose red color. So now run the code. So now it create only for the single class, and there is no background. Okay, so we find out this type of map, and we find out this type of place for that water body. Okay, but this type of water is not available in the dry season, but in the rainy season we find out for this type of place water. Okay, so if you want, you can also create suppose another class for dry season. Suppose we are just put the thresholding technique on the dry season in AWI, then we can easily compare this result also. Suppose we already create the map in AWI dry. So now we are just create this only stack the water body. So for that I simply, okay, just I take the another variable in here. So let's take a variable water area dry. So now call the dry in AWI, Control C and Control V. So put here the getter then, so we can check which value is the more better. So we can easily find out from here. You can see, so 0.008 or 0.004. So greater than all of pixel 0.004 indicating for water body. So just I put 0.004. So just put here 0.004. Again create the layer, just map dot add layer and call this water area dry, and also put the self marks because I create without background. Just put at the self marks single class, and this water I want to show just plated and put the plate suppose as a blue color. Okay, I put it say dry water. And now try to check. Okay, so we find out this some permanent water body in here, blue color. Otherwise all of water for that rainy season water. This type of place you can see. Okay, this type of place we find out that. Okay. So now we'll calculate how much area for rainy season water. We just try to calculate the area. Okay, so now we try to calculate this area for rainy season water. How much area? We find out that. So for calculating the area, we are just always we try to use. So it's a pixel. So for that, simply search for ee dot image dot pixel area. Okay, this function you have to use. So this function mainly calculate the image area, pixel area in a square meter unit. So further, we can easily convert the unit in other units, suppose a square kilometer or hectare. We can simply convert it. So let's go try to apply this function and then calculate the area. So further, just take a variable, suppose area, and then just put the function ee dot image dot pixel area, and this function it show the result square meter. Suppose I need the result in square kilometer. So for a square kilometer, just put here divide function, divide with 1 into 10 to the 6, 1e6. Then it convert the unit in a square kilometer, and further put here dot add bands, and I want to calculate the area for this rainy season water. Just copy and paste here, and then further use a function reduce region. Okay, so this function lot of time we use for calculating the statistical value. In this case, I want to calculate for total area. Suppose you need to calculate for average result or maximum result, minimum result. So different types of statistical value when you calculate for a specific boundary, then we just use this function reduce region function. If you simply search here about this function, suppose just put here reduce region. So we find out two types of function, reduce region and reduce regions. Okay, so further let's discuss about this function. So now we talk about this reduce region. So basically apply a reducer to all the pixel in a specific region. So mainly it calculates the different types of statistical value, suppose total area or mean value, average value, maximum value. So this type of things when you calculate for a specific boundary, then we are just use here this reduce region function. So I want to apply this function, just copy and further I will write the function in here. Just I paste all of argument and put here the dot notation. So further just make a dictionary, curly bracket start, and also curly bracket int. And reducer, it's an statistical function. I want to calculate total area. So for that use here ee dot reducer dot sum. Geometry, it's your shapefile variable name. So put here ROI. Scale 10 meter pixel size, and others not need, just I remove. Okay, so now just print this area, just print area and run. Okay, so we find out this type of result. Here you can see we find out that area, this is the total area, 298.91, okay, square kilometer. Suppose I need the result in hectare, so for that simply use here the multiply with 1 into 10 inverse 4, scientific notation 1e minus 4. So now it calculate the result in hectare unit, total area. So you find out this is the total area in hectare unit, total area hectare unit. You find out that when you need the result for square kilometer, just put here the divide function and then divide into 1 is 6, then you can easily get the result for hectare. Okay, so this is the process. I hope you can get the idea. This same approach we also apply for the flood mapping. Okay, so now I try to explain about that. But thresholding technique or also get the proper best value for threshold value using the outshoe, just we are applying the same process also for mainly in this case we talk about the before flood and after flood. So let's go try to show you the practical example. Okay, let me open a previous code, just a minute. Okay, so let me show you the code from the browser first. So in this case we have tried to work for this flood, and if you check the result first, then I talk explain the code. So in this case, just try to use here the Sentinel-1 SAR data. So mainly filtering the Sentinel-1 SAR data for the before flood and after flood. And then further just applying this thresholding technique and find out that best value. Then we just extract the water body and also flood water body. So if you check the result, first one, all of layer I try to explain. So here you can see this is the before flood. Sorry, this is the before flood condition. Okay, this is the before flood imagery. So in the before flood, basically this type of black color, this type of black color pixel indicating about the water body. Okay, this type of black color indicating about the water body, and this is the before flood condition. We find out this type of pixel, and if I just open the after flood, you can see the water body increased. We find out that it increased lot of water body. Okay, for the flood water it increased. Okay, so now we after getting the imagery for this image, we mainly find out from Sentinel-1 SAR data. Just we filter before flood and after flood for a specific time period. And then if you check the before filtered, so basically further this two layer, in this two layer we simply remove all of speckle. Basically in the Sentinel SAR data we find out this type of noisy pixel. So just filtering this type of noisy pixel from before filtered imagery and also after filter after flood imagery, just remove all of those, and then find out the flood inundation. So we find out that this type of red color indicating about that flood water, and also check the water body. We find out that this is the permanent water body. So now how I can generate this type of code, I will try to explain, then I hope you can easily get this idea. So in this case we are also applying this outshoe method to find out that best value for classify water body and flood water body. So let's go. So in this case, first of all, just simply import your study area. Suppose in this case, just I simply import my study area for the slate, and further just call the Sentinel-1 SAR data, so we can easily get this imagery from this collection. This not just back. Yeah, this one Sentinel-1 SAR data. So just copy this collection snippet from here and then paste. in here. Okay, so now this data set we filtering, so different purpose we need to filtering the data different. So in this case I try to work with VS band, mainly transmitter receiver polarization. This band I use, and transmit mode we just put at the IW, and I take the ascending and descending orbit pass, we take the both of, you can see that this is the descending as well as also take the ascending, okay, orbit properties. And further this is our collection. This collection simply filter for the 2 time period. So just I call the collection and filter, suppose this is the before flood and this one is for after flood. Okay, and then we are just selecting for a specific band VS. Okay, and further create the mosaic composite and click with our study area, and then we try to display this type of imagery. Suppose this imagery before and after. This is the before and this is the after. Okay, now so after getting the imagery we try to remove all of unnecessary pixel, mainly speckle, all of pixel we remove. So for that we have to use the very long code. So just I show you that it start from the speckle filtering function, it will be start from here, and last there are a lot of method we are applying in here. So this code I not explain in this time. Okay, just I try to show you that how we can connect this, and all time this is the same. Okay, this is the same code you have to use for speckle filtering function. Okay, so in this case here you can see I just create the function variable name to natural and to dv. So these two function we simply connecting with our imagery, then this full function automatically connect with our imagery. So this is the this code mainly fixed for all of analysis. Basically it remove all of unnecessary pixel from that your SAR imagery, it automatically remove. So now this is my function variable name which is, okay, just a minute. Okay, this is the function variable name to db and to natural. So these two function I simply implement in my code, you can see. Okay, so just I call the before filter, I take a variable name and call the before image and also after image. So connecting 2db and 2 natural, 2db and 2 natural. So when I connecting, then this two variable store it, mainly store it only for that your all of, remove all of noisy pixel, mainly speckle, and store it this. So further we try to add this two imagery after filtering. After filtering we can get this is the before filtered and this is the after filtered. Okay, so now further we are applying the same process for thresholding. So in this case I already checked the thresholding technique for my study area, but when you try to check which value is the for your thresholding technique, just apply the same process. So simply call the before filtered imagery and then create this type of histogram. Okay, so from this histogram you can easily find out that, suppose in this case I find out that greater than, you can see greater than 0.2 for my for this study area. So this same process you can also calculate, creating the chart, and from the chart take the decision which value is the more better, okay, which is the accurate value. Okay, so in this case we find out 0.2. So for my code I already check it, so I find out this result is the 0. Minus 20. So for that, for the indicating the flood water, I take the greater than minus 20 and also less than minus 20 from after filtered. Okay, so before filtered, mainly before flood, greater than minus 20, and after flood I take the less than minus 20 and create this type of layer. So you can find out this is the flood inundation. Just this is the main part to find out the best value. Okay, so when you try to find out the best value, then you can easily separate or segment or make the classification for the flood water and permanent water. So then further we take this another one. So before filtered less than minus 20 and after filtered flood less than minus 20, so it's a permanent water body. So further we try to visualize this type of map. Okay, and then it also calculate the total district area, mainly total boundary area. So for that I just call the ROI, because ROI is stored the total boundary shape file, and I put the area and divided this value, then we can easily get the result. And further, for calculating the flood water, so just I call the same process flood marks. Basically it stored that flood, you can see this variable stored the flood inundation area. So just call the flood marks and multiply with this function, and it'll use the reduced region function to calculate the total area of flood. So you can easily find out that all of information from here. Okay, so you find out this is the total flood area, how much area flooded, and this is the total district area, it also calculated. So I also send you this code. You also try to do this type of flood and also non-flood or permanent water body. Try to make the classify and then check. Okay. So this important part is that find out the thresholding value. Okay. So when you find out the thresholding value, just put the value. And how we can easily find out the thresholding value? Just we are applying the ORTSHU method. Okay. And then find out the thresholding value. The same approach which I show you in this code. This same approach also try to apply. Then I hope you can get the idea. Okay, so any question, please?
So in other softwares, the also method is usually like a built-in function. Is it the same here, or we just have to
Yes,
find those
yes,
values
yes.
on ourselves?
It also, okay, so it also possible to use some built-in function to find out the ORTSHU method. So it's called that we also, okay, so I'll show you this part process also. Suppose if you want, you can also use at the Open Earth Engine library. Okay, so simply search here Open Earth Engine library. So from this Open Earth Engine library, we can easily find out different types of function, built-in function. Okay, so if you check it, so I think you can easily get it. So here you can see this is the ORTSHU threshold. Okay, so this one kind of, okay, just let me check it. So in this case you can see, okay, so this is the full code. Okay, so this is the full code about that, for that ORTSHU. Okay, so basically these things is also we also use shortly. Okay, also you can see, okay, so if you want, you can simply copy the code, full code, and also work with for the ORTSHU. But I think it also create for another. Okay, let me show you that. Okay, so for that we also use that. Suppose this code I want to apply this library, and this library called that Open Earth Engine library. So Open Earth Engine library. So it provide one kinds of external library. Suppose this type of function is not available in the docs tab, but different types of developer, they are created different types of library. Okay, so we already know about that R have different types of library. So this type of Open Earth Engine library we are also use for identify. So for that, when you apply this library, suppose I take a variable, just take a variable, suppose OE Open Earth Engine library, and then I simply call this library name. So this library, for that, when you just put at the required. Okay, so required, then this function mainly in this case, just you simply put the Open Earth Engine library asset ID. Okay, so for the ORTSHU asset ID is that, so I simply write here, it's a users slash Open Earth Engine library. So I put here that load all. Okay, so in this is the way, or mainly this is the path, Open Earth Engine library. So I load all function. Okay, so now we can easily work with the ORTSHU also. So now how I can apply it. So for applying these things, just take a variable, suppose ORTSHU, and then call this variable name, and then use your image collection dot ORTSHU threshold. Okay, and then call your image, which image you want to apply the outshoe. So I want to apply, suppose, for NDWI rainy. Just I copy and then paste here. Okay, this imagery already have one band of NDWI. If you want, you can also mention the band name, suppose NDWI. So this is the band name we already created in this imagery, in this NDWI map. Okay, and further, if you want, you can easily make the chart. Suppose for the chart, just use here take a variable, suppose chart 2, and then I put here UI dot chart dot image dot histogram. Okay, and I just call this variable name outshoe and paste here, and further call the study area ROI and zoom level. This my resolution 10 meter. So now print chart 2. So now it also create the chart. Okay, it's for the wrong. Okay, show that in users. But was error. Okay, okay. So this problem is that this things is work for that collection, image collection, but in this case, basically this function, mainly open earth engine library, is only work for image collection. But in this case, I put here image, so basically it's a NWI image, single image. So that's why we find out this type of problem. But if you want, okay, I'll show the example, then it's more better. Okay, so let me open a new code. So I need the collection. So basically when you apply this type of outshoe built-in function, mainly open earth engine library, we try to apply some built-in function for outshoe method, then we need to create the image collection, and from this image collection we can easily apply this type of function. So that's why in this time I just create from in this time this NWI, it's just a single image, not the image collection. So that's why it show in users input should be type of image collection. Okay, but in this case I just apply it for image, so that's why it show the wrong or error. So these things we also apply. Suppose let me open the same code, copy the same code from here, and then try to apply for the image collection. Okay, so now we just create the image collection. Okay, just I copy all of from here and then paste. Okay, and also import my study area. Suppose Dhaka city, and I put it say ROI. So now I just create the collection, mainly I just create the image collection. So in this case I just use this type of function, and if I check how much image is available in my collection, it show the this type of image is available for this collection. But if you check all of images, okay, I also filtered suppose a specific time, then it will short. Suppose I want to filter, just put here the filter date function and filter this image for a specific time period. Suppose year of 2020, 1st January, from year of 2020, suppose December 31, I take for 1 year. So now let's check how much image is available. We find out the 146. So this 146 images I have. So this is my collection. So this collection I can easily apply this type of open earth engine library. This mainly this function, open earth engine library, I can easily apply. But in this case I want to create the collection for NDWI, okay, because I want to apply the thresholding technique in the NDWI and then make the class water and non-water. So this is my main target. So if you check for the Sentinel all of image information, if you check, just run it, you will find out there is no no band for NDWI. You can see all of imagery, all of bands. Suppose I check this band, you can see there is no band about NDWI, okay. But for my work, I want to create the band of NDWI because I want to apply the thresholding technique, mainly outshoot technique, in NDWI map, and further I want to separate the water and non-water. So this is my main goal. So for that I need to create a band of NDWI, okay. In this time, this variable is stored only for those band which are available in the satellite, but there is no external band. So now I want to create the band, external band of NDWI, and further apply. For creating this band, we are just create a function, okay. Suppose I just create a function. Suppose I put the element name is a image img. You can put any name as an element, and further curly bracket. In this curly bracket, just I put my argument. So my argument is that I want to use this image, I want to use this element, and further I want to create the band of NDWI, okay. So for that we just simply calculate the NDWI. So let's go, just take a variable, suppose NDWI equal, I call this element name, okay. Just I call the element name is that img, and then put the function normalize difference. I put here normalize difference between two band, mainly B3, and also put here that B8, okay. And further I rename it, I put the rename suppose NDWI. So now what I return from here, my ultimate goal is that this NDWI work as a band. So for that just put here the return this element add bands, and call this variable name, just copy and paste here. So now I create a function, okay. So this is a function, I create a function. This function help me to create the band of NDWI, and this function I want to connect with my image collection, and this is my image collection. I already create the image collection, basically Sentinel, this variable is the image collection. And how much image, we already check it, mainly we find out that 146 images, okay. And this function I created. So now this function I want to connect with my image collection. So we already discussed about that when I talk about that, mainly rescaling for modis NDVI data, or also LST for calculating the modis LST. So this function I want to connect with my image collection. This is my image collection. For connecting, we are just use here the dot map function. Put the parenthesis and also close this parenthesis in the last part. Just close in here. So now if you check, just run it. All of images also include a new band. This band name is NDWI. So if you check the image band, we find out the new band of NDWI, okay. So now it work as a image collection, okay. Now it's work as a image collection. All of images create the new band, and this band name is the NDWI. So now I can easily apply Open Earth Engine library, and further I create that outshoot. I can apply the outshoot and find out that proper threshold value and segment water and non-water. Same process you can say apply for vegetation or non-vegetation using NDVI. Suppose you want to create the NDVI map, and now you want to just make the class vegetation and non-vegetation, okay. So which value is the more better for your image, you don't know, just apply the outshoot technique, and then you can easily find out the vegetation and non-vegetation area using the outshoot. So let's go try to apply the outshoot in this time, because I create the image collection. So now this code is easily work. Just I copy from here and apply this code in here, just Ctrl and V. So now in this case it also same, just I call the all of open earth engine library, I load and store it in here, and further I take a variable, and this is a function, it's also function. Okay, so basically image collection or true threshold, it's one kind of function, but this function is come from this open earth engine library. Okay, it's not come from the doc step. Okay, if I just it come from the doc step, then it show about that whole pink color. In this time it not show the whole pink color, because this function come from this open earth engine library. From here it's come, and now I just call my image collection, suppose sentinel, it is stored all of image collection, and now I want to apply for thresholding technique for NDWI. I already create the NDWI band, you can see all of image stored the NDWI band. So now if I just run the code, I hope there is no problem. So okay, let me run the code. Okay, it's working. And it takes some time in this time, because this function basic true threshold value is come from the not come from the doc step, it's come from the open earth engine library. So for the connecting this function it takes some time, because it's come from the other sources, not from the Google Earth Engine server. It come from the open earth engine library. So that's why it for loading, when you use this type of others library, then for loading or creating the result it takes some time. Yes please. Yes please.
In this case, I can see we are going to do the threshold for only, yeah, for all the images. But then how do we do now the differences between the dry and the wet? Or it's going to do it for everyone and then we do the difference on ourselves?
So for that we just create the image and then apply this type of histogram, and from this histogram we can easily check the result from the chart. Okay, from
Yeah,
the chart.
because my thinking was I wanted to do this for like several images. So checking the histogram for each and every image. For example, I wanted to do a flood history mapping. So if I was to check the histogram for all of them, I was hoping for an automated process.
Yeah, so if you want to check it all of images one by one, suppose in this case I just take the time period year of full year. Okay, suppose you just simply put here the flood time period. Okay, flood time period, suppose for a specific month or a specific season, and then check the value. Okay, suppose before flood and after flood. Okay, just check the value, and then you can get the decision which is the more better for classify. It also takes time, because it's a not, it cannot come from the docs function, it's come from the open earth engine library. Okay, and this all of open earth engine library is basically it's work only for the collection, image collection. So that's why we are just create the image collection of NDWI between all of images which are available between this time period, and then further we apply it.